CBSE Class 12 2016 Class 12. The section A we begin. First one. I have a question in the first one. Students are requested to take the question paper. I write the only question, that is angle A is 1 by modulus of A is 1 by 2 is given. The modulus of B is given 4 upon root 3. Modulus of A cross B is given 1 upon root 3. He is asking us to find A bar dot B bar modulus. So here, how do we find this one? What is A bar dot B bar? We are getting A bar dot B bar dot product is mod A mod B cos theta. Magnitude of A bar cross B bar is but mod A mod B sin theta. Then if I do this, mod A mod B whole square plus magnitude of A bar cross B bar whole square, I am getting here mod A square mod B square common with cos square plus sin square. So I am doing a squaring on both sides and adding it. So this will become 1. So finally you have this one is 1 by root 3 square, that is 1 by 3. I am talking about A bar dot B bar ka square, and the modulus of A square is 1 by 4 into 4 by root 3 means 16 by 3 into 1. This is 4 1s and 4 4s. 1 by 3 coming here. A bar dot B bar ka square is 4 by 3 minus 1 by 3. This is 3 by 3. This is 1. So we finally get A bar dot B bar is equal to 1. Question number 2. 2 question is given magnitude of A and magnitude of B. These both are unit vectors is given, and we have to find if suppose A bar minus root 2 B bar is also unit vector if you have, find angle between A bar and B bar. This is what the question. So now I have got magnitude of A and magnitude of B is equal to 1. She has given the modulus of A bar minus root 2 B bar is also 1 if suppose. That means, what does it mean? A bar minus root 2 B bar dot A bar minus root 2 B bar should be equal to 1. Now when you do the dot product here, A bar dot A bar minus root 2 times A bar dot B bar minus root 2 times B bar dot A bar. I am doing a dot product here. Minus of minus, remember here, plus root 2 into root 2, 2 times B bar dot B bar equal to 1. Now A bar dot A bar means modulus of A square minus this time it is 2 times 2 root 2 A bar dot B bar. You can write because this scalar product is commutative. Then plus 2 mod B square is equal to 1. Mod B and mod A are 1. That means 1 and here plus 2. This is totally, so 3 minus 2 root 2 A bar dot B bar, answer is 1. 3 going other side, minus 2 root 2 A bar dot B bar is 3 going other side is minus 2. So that means A bar dot B bar, so minus 2 gets cancelled, will become 1 upon root 2. So you need to find angle between A bar dot B bar, that is cos theta is A bar dot B bar by magnitude of A and magnitude of B, which you know. 1 upon root 2, magnitude of A is unit vector and B also unit vector, so 1 upon root 2 only answer. That means theta is pi by 4. Question number 3 here. I have here question number 3, distance between plane. Distance between planes. Remember always this distance between the planes will be of parallel planes. Is given question r bar dot 2i minus 3j plus 6k minus 4 equal to 0. This is first plane. R bar dot 6i minus 9j plus 18k plus 30 equal to 0. Now these two planes, if you see this, here 2 and here 6, here 3 and it's 9, here 6 and 18, means this should be multiplied with what, 3, so that these both will be same. So these two are parallel planes. Let me take first in the plane form r bar. This is vector form. Cartesian form, it will become 2x minus 3y plus 6z minus 4 equal to 0. As you know, r bar is xi plus yj plus zk, and here 6x minus 9y plus 18z plus 30 equal to 0. This is first one and this is second one, and this you should multiply with 3. When you multiply with 3, it will be 6x minus 9y plus 18z. Okay, 3 when you multiply, minus 12. So what is the parallel distance formula? Modulus of the difference of the constant, because all are same. So d1 minus d2 by root of a square plus b square plus c square. Now what is the difference here? 30 and minus of minus plus, that is 42. 30 plus 42 by root of a square, 36 plus 81 plus 18 square, 324. Student are requested to add this and get the simplification. Now question number 4. 4 is a very simple one. The magnitude of A is 5. Sorry, the modulus, no, it is matrices. Determinant of A is 5. We have to find out determinant of A bar dot A transpose. Okay, if A is having determinant 5, A transpose also will have a determinant 5. So that means, one second, let me shift this one. I have a small gap here, so the video would be much better, I think, with this good clarity. So sorry for disturbance here. Now determinant of A is 5. I hope the determinant of A into determinant of A transpose you can write. That means there is a property, determinant of AB can be written det A into det B. So here determinant of A into A transpose also can be written determinant of A into determinant of A transpose. So this is 5 into, this doesn't change, so it is 5 again. So 25 is the answer. Question number 5. Now question number 5 is also in the matrix. A is having 1, 2, 3 and minus 1. B is having 1, minus 4, 3 and minus 2. So we need to find determinant of AB. This you can do it in this formula, or else you can find the matrix multiplication. So suppose matrix multiplication, if you multiply row with column, 1 into 1, 1, 2 into 3 plus 6, 1 into minus 4, minus 4, 2 into minus 2, minus 4, and 3 into 1, 3, minus 1 into 3, minus 3, 3 into, next is 4, minus 4, minus 12, minus of minus plus 2. So this will be 7, minus 8, 0 and minus 10. So determinant is what? Oh sorry, it's a small problem. The determinant is minus 70. Now question number 6 is also from the matrix. So A is equal to 0, 3, 2 and minus 5. Ka is equal to 0, 4a minus 8 and 5b. We should find small k and small a. Here if I look at k, this is first elements are same, but if you look at this 2 and this is minus 8, that means 2 you should multiply with minus 4. So if you multiply with minus 4 here, we are getting 0, and then here minus 12, minus 8, and this is plus 20. So now k is nothing but your minus 4, and 4a equal to minus 12, a is minus 3, and 5b equal to 20, and b equal to 4. This is how you can solve easily. Now I go to some little big questions. Let's increase the speed of solving the questions. So here in the section B we have reached. This is seventh question. Now seventh question is differentiating sine 2x power x plus sine inverse root 3 and x. See, x is also having root 3. Now when you have this function, I told you to take u as, suppose this is y is equal to, okay, the question is always written y is equal to sine 2x power x plus sine inverse root 3x. Now this is u. Why we have taken this is u? So this is sine 2x whole power x, and we am taking sine inverse under root 3, and under root x is also there. Don't forget that. Now this is having a power x, so that should be brought down, so I apply log. Always remember, when a power to be brought down, I apply log, so it will become x will come down, so you have a log of sine 2x. Now what is the differentiation? This is 1 by u du by dx. First one is what? This is u-way rule, so x into log of sine 2x will be 1 upon sine 2x into sine differentiation cos 2x into 2x differentiation 2, done, plus sine 2x into, sorry, this is log of sine 2x. Remember while solving these questions, x into 1. So finally, what is your du by dx? We have got 2x cot 2x plus log of sine 2x. This whole thing is multiplied with u. What is u here? Sine 2x whole power x. This is about du by dx. Now we have sine inverse under root 3 into x. Now if you do this directly, du by dx, sine inverse differentiation formula, we have 1 upon under root 1 minus x square, means root 3 and x is having a square. So again root 3x you should differentiate. Root 3 comes out, root x is 1 by 2 root x. Remember, we are doing internal differentiations also. Now finally, what is your dy by dx? The differentiation part. So this is sine 2x power x multiply with 2x cot 2x plus log of sine 2x, the first part completed, plus 1 upon under root 1 minus 3x into root 3 by 2 root x. This is how we have solved it. This is having a sub question also. You can also have an option to do another one, that is tan inverse of under root 1 minus x square, sorry, it's 1 plus x square, then 1 minus x square by under root of 1 plus x square plus under root of 1 minus x square. When you get these type of questions, I told you when plus and minus is there, two things we have to put. X square is equal to cos theta. Now let us see in the next question how it goes. Now x square is equal to cos theta you kept. That means your y will become tan inverse under root of 1 plus cos theta minus under root of 1 minus cos theta divided by under root of 1 plus cos theta plus under root of 1 minus cos theta. 1 plus cos theta is what? There is a direct formula. This is under root of 2 sine square theta by 2, and then sorry, plus comes means it is cos square. 2 cos square theta by 2 under root of, again here 2 sine square theta by 2, half angle formulas. Under root of 2 cos square theta by 2 plus under root of 2 sine square theta by 2. Now when you can cancel the root, means root 2 can take common, and I get tan inverse of cos theta by 2 minus sine theta by 2 divided by cos theta by 2 plus sine theta by 2. Don't confuse, I didn't cancel this. This is the division. Sorry, division should be proper. So cos common. So tan inverse cos common here. So 1 minus tan theta by 2 divided by 1 plus tan theta by 2. This is having a same formula because I wanted to convert this into tan, and this I can write tan pi by 4. So you have a formula directly. This is tan inverse tan of pi by 4 minus theta by 2. Minus comes because numerator is minus. Tan inverse and tan gets cancelled, so I got pi by 4 minus half theta. That means y equal to pi by 4 minus half. What was theta? That is cos inverse of x square. Now when you differentiate this part, the differentiation of constant is 0 and then half is multiplied here, so it is cos inverse means minus 1 upon under root 1 minus x square is having a whole square, and internal differentiation 2x because x square. So final answer you can write here 2 and 2 gets cancelled, minus plus, that is x upon under root 1 minus x power 4. So we could able to complete this a little fast. So now we have reached another question, that is question number 9 in your paper, that is ay square is equal to x cube, x coordinate is am square. We need to find the normal for this equation. Once again there is a small so now let's come back. X coordinate, this is not x axis, this is x coordinate is am square. Now what would be y coordinate if it is x here? So ay square is equal to am square is having means a cube m power 6. So this is y square is equal to a square m power 6 or am cube whole square. Can you write like this? So x is having am square, so y also you are getting am square or am cube, sorry, am cube you are getting. So the point is am square comma am cube, this is the point. We need to find that this one is normal. So for this normal, first we should find the slope of tangents. That means y square, which was given, equal to x cube by a. Now y square differentiation, if you do dy by dx is equal to 3x square by a. Now when you put these points here, slope of tangent when you take, that should be dy by dx at a point am square comma am cube. Now what is dy by dx from here? Dy by dx from here we have not solved completely, so this is 3x square by 2a and y. Now we put this one reduce here, so 3x square means a square m power 4 by 2a into, and here we got a m cube. That means a square get cancelled, m cube and m power 4 become m, so 3 by 2 m. Now we have a slope of tangent, that but slope of normal will be something minus 1 by slope of tangent because they both are perpendicular. That means it should be minus 2 by 3m. Now what was the normal equation? Normal equation is so simple. Y minus, what is y1? am cube is equal to minus 2 by 3m, that is the slope, into x minus am square. Simplify this, you'll get the answer. Now we've reached the question number 10, I believe. Sorry, 9 we did, so 8 we have not done, so let's do 8. This is on continuity. He has given f of x is equal to k times sine pi by 2 plus x, and other one is tan x minus sine x upon x cube. This is for x less than or equal to 0, and this is for x greater than 0, and is given x continuous at x equal to 0. Means I can apply limit x tends to 0 f of x is equal to f of 0. What is f of 0? This is less than or equal to, so this one you can apply. That means k into sine pi by 2 plus 0. I can put the value of x over here because sine pi by 2 is 1, so answer is k here. k we are supposed to find, but left side I cannot put the limit directly. So if you take it is tan x minus sin x by x cube. I cannot put 0 because if tan 0 minus sin 0, that will become 0 by 0 cube is 0 by 0, you will get this is undetermined, so you cannot put that. So let us simplify this. Tan, you can initially get an idea to write sin by cos, sin x by cos x minus 1 more sin x is available by x cube. So when you take this sin x common, and I get cos x LCM, so it will become 1 minus cos x. Remember, by x cube is there, okay, is equal to k. Once again, sin I have taken common, so it has gone 1 by cos minus 1 only, so we have taken LCM, so we got 1 minus cos x by cos x. We print little fast. Sin x by x cube is there, so x cube for sin x 1x you can take and you will get one answer. So we can write this as sin x by x into 1 minus cos x is 2 sin square x by 2 by 1 more x square you can write here into 1 by cos x is equal to k. Now when you see this is a limit formula, this is 1 and 2 is here, you can write 2, this square and this is square, so you should have 1 by 2 is having a square. You can put the value of 0 in cos because cos 0 is 1 is equal to k. That is 2 into 1 by 4 equal to k, and then k equal to 1 by 2. 2 minutes. Now we'll have a continuation. This is we have reached the 10th question. So now we have integration part, 1 minus sin x upon now sin x into 1 plus sin x into dx. See this integration part, it's so simple. How do we do this? Write numerator using denominator. We always reason this, how to write numerator using denominator. 1 second. So we have 1 plus sin x here, so I write 1 plus sin x blindly, and I need only minus sin x over there, so sin x should be subtracted with minus 2 sin x. So you got the numerator. We have written numerator using denominator, so 1 plus sin x is used, so you should put this in bracket, and that minus 2 sin x has taken minus sin x. Now I can cancel the sum. I can divide separately. So if you divide these two, this will cancel. I get 1 by sine, that 1 by sine, that is cosecant, you can write directly, minus, when you divide the sine get cancelled, you will get 2 upon 1 plus sine. So this is what you have to integrate. Now cosecant x integration is, you already have, this is log mod cosecant x minus cot x. First part is done. Minus 2 integral. I have 1 upon 1 plus sin x. Rationalize this. 1 minus sin x by 1 plus sin x into 1 minus sin x. So the down part will become cos square, because it is 1 minus sin square, so it will become cos square. Log of cosecant x minus cot x minus 2 integral 1 minus sin x divided by cos square x. Now when you divide separately, you get log of cosecant x minus cot x minus, now divide 1 by cos square is secant square, so secant square integration is tan x. We are moving a little fast. Minus into minus plus, we will have got integration. 1 by cos square is secant square integration tan we have taken. Sin by cos square means sin by cos is, one is tan and one is secant. So secant x tan x is again secant x. So log of cosecant x minus cot x at the beginning minus 2 tan x plus secant x plus c. So this is how we have done this question number 10. So it is looking a little lengthy, but the answers are very easy. Now question number 11, it is very challenging. Log of log x plus 1 upon log x whole square into dx. This you should integrate. When you have a question like this, or blindly think as log x to be kept as t. Okay, so then x will become, because there is no other thing, the x you should find. So x you find out it as e power t dt. Oh, sorry, x is e power t. I'm going to proceed at first. Dx become e power t dt. Now my dear, here we have taken log x equal to t. Now integration part become log t plus 1 upon t square into dx is e power t dt. When you have e power t outside, you should have a function and its derivative inside. That is a formula. Like when you have e power x outside, we have to have a function with its derivative inside. That could be written as e power x into f of x. So this formula we have to use here because e power t is seen out. Now log t is a function. Suppose its differentiation is 1 by t, but here 1 by t square is there. So what you should think is log t is 1, differentiation is 1 by t, which is not there. So I write 1 by t minus 1 by t plus 1 by t square. So here added with the and subtracted with the 1 by t. So that log t differentiation is 1 by t minus 1 by t differentiation is 1 by t square. So that means you have differentiated these two functions are f of x and f dash of x is these two. So you can write it as e power t into log t minus 1 by t plus c. Now what is e power t at the beginning? E power t at the beginning is x. Log t, what is log t? But what is t here? Log x? No. So this is log of log x minus I have here 1 by log x plus c. This is your final answer. Now I have another question here. Let me complete most part of this question paper. Question number 12, that is 0 to pi by 2. I have a sine square x by, this is very simple, that is the reason I have taken it fast. Otherwise we can complete this with another part, but this is a definite integration 0 to pi by 2 sine square by sine x plus cos x. So here I cannot do integration by any method, so I told you when you cannot do that, replace x with a plus b minus x means pi by 2 minus x. So your I will become 0 to pi by 2 integral sine square pi by 2 minus x by sine pi by 2 minus x plus cos pi by 2 minus x. Now my dears, when you are substituting before that, this is 1 and the substituted part which you can simplify further, that is 0 to pi by 2 integral sine square will now become cos square x upon this is cos x plus sine x dx. Now adding 1 and 2, this is your 2. Okay, adding 1 and 2, you will be getting 2i is equal to integral 0 to pi by 2 here cos square, and the up one is sine square plus cos square. You can do because the denominator is same. So sine square plus cos square is 1 upon sine x plus cos x. Now how do we do this sum? Sine x plus cos x. So this one I can do in many methods. There is another method, but what I do is I use a normal form which we have learned in the last year. 0 to pi by 2, right? 1 upon, let me take here 1 is there and here 1 is there, root of a square plus b square. You divide and multiply, we have got that. Root of a square plus b square means a is 1 and b is 1, root 1 plus 1, that is root 2. So we are dividing and multiplying with root 2. 1 by root 2 sine x plus 1 by root 2 cos x. This 1 by root 2 you can write cos or sine, your wish. So I get 1 by root 2 outside, integral 0 to pi by 2 1 upon, suppose cos you are writing, so this is sine x cos pi by 4 plus sine cos x sine pi by 4. It may not be looking good, but I'll write in the next step. This is sine a cos b plus cos a sine b. That is sine a plus b. So integral 0 to pi by 2, 1 by root 2 was outside. This is 2i we are doing. Sorry, 2i we are doing. So dx upon sine of x plus pi by 4. 1 by sine is cos, 1 by sine is cosecant. 1 by root 2 log of, I'm going a little fast. This is cosecant x plus pi by 4 dx. Now cosecant is, there is a cosecant x formula, log mod tan half angle, that is x by 2 plus pi by 8, and this is 0 to pi by 2. Now we can put the values of x, upper limit and lower limit, and get the answer. Better try to do that. Now we will shift our focus on the next question. You have an option here, that is integral 0 to 1 cot inverse 1 minus x plus x square dx. I think it should be a last question, because more than half an hour no one is willing to see the video. I just take this one as the last one. Now 1 I'm taking separately, x square minus x is there, so first thing into x minus 1 I'm writing. See this arrangement how I did. I made it look so simple, but it is not that simple. X square and x is having a variable, so I put one separate, remaining in positive and negative form. Then you take x common over here. When you are writing like this is in cot inverse. Formulas in cot inverse are not known, but when you make it in tan inverse, it will become a reciprocal, that is 1 upon 1 plus x into x minus 1. Now when you have in a denominator 1 plus, numerator should be subtraction of two terms. How do we get 1 if you subtract these two? If you think in that way, this should be x minus of x minus 1, so 1 plus x into x minus 1 dx. See this, x minus of x minus 1, x and x cancel, I get plus 1, which is what in the numerator. So we made it look so simple. Now we got a tan inverse x minus tan inverse y formula, so that can be applied right now. Now this one here your focus should be. So integral 0 to 1, I have a tan inverse x minus tan inverse x minus 1. Now you have got these two. Even you have reached till here, so we have to get Euler rule done. Euler rule, you know, u is tan inverse x suppose, and v is 1. The differentiation is 1 by 1 plus x square, integration is x. In the same way here, u is tan inverse x minus 1, v is 1. The differentiation is 1 by 1 plus x minus 1 whole square, and the v1 integration is x. Now what was the formula we have? Integral uv is uv1 minus integration u dash v1 dx, the product rule. This formula, and using that formula I'll put that limits later. I have a slanted one, x into tan inverse x minus minus in the formula, okay, integration of x by 1 plus x square. This is having 0 to 1, don't forget that. Then I have a minus sign over here, okay, minus sign, so I'm putting minus sign over here. And 1 second, I will like to take this one also, cross multiplication and normal multiplication. Cross multiplication means x into tan inverse of x minus 1, then a minus in the formula, integral 0 to 1 is there here also. I put here 0 to 1, okay, I put here 0 to 1. After integration this we should do. Integral again here, what to do, x upon 1 plus x minus 1 whole square. If you expand, it should be x square minus 2x plus 1. Now what we make it here, we can integrate easily, divide and multiply with 2, so it is differentiation up. So I get x tan inverse x minus half log 1 plus x square, because f dash of x, f of x. Now here minus x tan inverse x minus 1 and plus integral 0 to 1. So here we got x square minus 2x plus 2, but here only x. But here this one you should do little sub question you can take and do, like now this is what actually x upon x square minus 2x plus 2. I would like to take a differentiation up. That means you should have a 2x, because x square differentiation is rough work if you take 2x minus 2, right? 2x minus 2 must be 2x minus 2, very different. 2x minus 2 must be numerator. 2x means if you want to make this x as 2x, you divide and multiply with 2x. I got 2x now. Minus 2 is required, so put a minus 2 plus 2. This is how you can change this, and you make it two separate parts. So this is half. If you make this one, this is log, you will get, no need of thinking much, x square minus 2x plus 2. And when you are taking this, 2 and half will become 2 and half will cancel and you will get 1. Integral 1 by this one, already you know, x minus 1 whole square plus 1. This is tan inverse. So half log x square minus 2x plus 2, and then this is tan inverse x minus 1. Put this value over there and apply the limits. We will do that continuation.